get started with our first spectrum, and what I've shown here are the 8 compounds that we've already analyzed and predicted the peaks for, because it turns out that the spectra we're going to be looking at from this point forward actually match one of these. So let's see if we can interpret the spectrum and then find out which structure it matches. So here's what we're going to do. We're going to read it from left to right just like we would a sentence, and we're going to start and look for our obvious peaks. So we start and we look around 3300 is where we find an alcohol, an OH. Do we have an alcohol here? Do we have an OH? We sure do. This big, broad peak around 3300 is exactly what an OH looks like. So we can point to it, we can circle it, we can do something to label it. Very clearly, though, we want to label, get in that habit of labeling our spectra. Okay, then we continue reading left to right, and we move to this 3000 mark, and we look just above 3000 for peaks, and sure enough, we see some peaks here. We also see some peaks just below 3000, so what does that tell us? Just above 3000 is where we find sp2CHs, and just below 3000 is where we find sp3CHs. Okay, we continue reading. We go to 2200. Here's 2200. We look for peaks there. Do we have a triple bond? There's no triple bond there. We continue to 1700. Here's 1700. Is there a carbonyl? Could that be a carbonyl, this little tiny peak? Could that be a carbonyl? No way. Remember, a carbonyl, biggest, strongest peak in your whole spectrum. So these are the obvious bands that you can't miss. So there's no carbonyl. There's no triple bond. Okay, so just based on these functional groups that we know are present, let's take a look at our structures 1 through 8 and decide which spectrum we have, what compound we have. Well, we know there's an OH, and actually there's only 2 choices that have OHs. How would we distinguish between 6 and 7? Well, there's 2 ways. One of them is 7 must have a carbonyl, and we know we don't have a carbonyl, right? We could just kind of make that note here, no carbonyl. Just as an FYI, I wouldn't really put that on my spectrum. Okay, but it can't be 7, so it must be 6. It has the OH, it has the sp2CH, it has the sp3CH. Okay, now what else can we look for? If we know it's 6 and we're thinking that it's 6, now let's go back and find some of those needles in the haystack that will more completely label this spectrum and give us further evidence. For example, because it has an aromatic ring, how would you describe that aromatic ring? It's a monosubstituted ring, so in fact, I see this aromatic ripple up here. That's consistent with the monosubstituted, 1, 2, 3, 4. And we also look to find, we should find 2 peaks around 700, 750. And there they are. So this is monosubstituted aromatic. We call this the out-of-plane bending. So this gives us more evidence for that structure. Okay, is there anything else? Maybe we could look for that CO stretch, and maybe one of these is a CO. All right, maybe we'll put a little question mark here. Right, there's 2 peaks here. I don't know for sure which is the CO. So, you know, that's nice to attempt to label, but some things we're not going to be able to identify with certainty. Okay, also with the benzene ring, maybe this peak around here at 1600 is the carbon-carbon double bond. You know, maybe we could put a little question mark there. I don't know for sure. That is, we would expect to find something around that region, so that's probably a good guess. Okay, let's try another one. So we'll start by reading the spectrum from left to right. The first thing we should be looking for around 3300 is an alcohol. Do we have any OHs? Well, we have this tiny little blip, but that sure doesn't look like anything significant. So we have no OH here. We continue to 3000. Here's 3000. We look just above, anything just above 3000, that's empty, so there's no sp2CH. We'll just put a little note up here on what we're seeing. How about just below 3000? Yeah, here we have our first peak, significant peak, so we'll label those. We have sp3CH. We continue down, reading left to right at 2200. Do we have any triple bonds? No triple bonds. And then we move down to 1700. At 1700, what do we find? We do have a carbonyl. Okay, again, a systematic approach means we're going to be looking for our obvious peaks, and we're not going to be missing them anytime they show up. So let's take a look at structures 1 through 8. what compound has a carbonyl and sp3ch and nothing else. Okay, so it can't be the carboxylic acid because it had no H. And we actually have 3 compounds with carbonyls, right? So we can cross these guys off as not being possible. These are our 3 contenders. How would we distinguish between them? These 2 are ketones. 1 and 4 are ketones, and 3 is an aldehyde. And there's something else that distinguishes them. How about our CHs? We said that there's no sp2ch, but 3 has a benzene ring and 4 has a benzene ring, so those cannot be our structures. So we actually have just one possibility here. This has to be this ketone, because all we have are sp3chs and carbonyl. Okay, is there anything else I can look for to label? Really, there's nothing else. So look at all those peaks in the fingerprint region that we're just leaving alone. Okay, sometimes that's going to be frustrating. So you might find that frustrating, but the key to solving IR problems is knowing which peaks are significant, being able to pick those out. We have to resist the temptation to label every single squiggle and wiggle because there's just simply no, these are not significant peaks. It's simply your molecule bending and wobbling all around, and that doesn't really tell us anything diagnostic. Okay, so just those 2 peaks are all we need to label and to positively identify its structure.